Hello students, in this class we shall study electric charges, which is the physics chapter 1 of class 12th, and in this chapter the first topic is Coulomb's law. So we shall study what is Coulomb's law and by illustrations, and we will try to solve some of the numericals to understand it, what is the Coulomb's law and what are its implications. So see, if there are two charges are there, let us say Q1 and Q2. These are the two charges which are separated by a distance of r. Then Coulomb law states that this charge Q1 exerts a force on Q2 and Q2 exerts a force on Q1. So this force F12 and F21, they are both equal and opposite in direction. So, and what is the magnitude? Magnitude of this force is directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between the two charges. So, Coulomb law has two parts. One is magnitude, and magnitude of the force between two charges exerted by the two charges on each other is directly proportional to product of the two charges, and it is inversely proportional to the square of the distance between the charges. So these are the two implications, and we can write it as, according to Coulomb's law, the force of attraction if Q1 and Q2 are both positive or both negative, then there will be force of repulsion. This you already know. अगर दोनों चार्जेस एक जैसे हैं, either both are positive or both are negative, then there will be force of repulsion. They will repel each other, and if Q1 is positive and Q2 is negative, then, and either Q1 is negative or it is positive, both are of different nature, different sign, then there will be force of attraction. Like charges repel each other, and different charges, positive and negative, they attract each other. So this is the illustration of Coulomb law. Now we shall try to study this Coulomb law in vector form. So let us assume two charges, that is, one is Q1 and other is Q2. Then what happens? This is origin, and Q2 has position vector R2 and Q1 has position vector R1. Q1 has position vector as R1 and Q2 has position vector R2. Now, if Q1 and Q2 are having both are positive in nature, then they will repel each other. And if we join this, then F12 here, it will be F12 in this direction, and here F21 in this direction. F12 is the force on charge Q1 due to charge Q2. Force on Q1 due to Q2. And F21 is the force on Q2 due to charge Q1. Now, here R21, this is the distance between Q1 and Q2. R21, if we see R21 as position vector, then R21 will be R2 minus R1. And if we see R12 position vector, then this will be R1 minus R2. And here we can say, by this vector form, we can say that R12 position vector is negative of R21. Now, we have seen by Coulomb law that force is directly proportional to product of charges, and it is indirectly proportional to square of the distance. And if we see that F12 is equal to F12 is a force on charge Q1 due to Q2, this will be equal to 1 by, and here we say that F is equal to K Q1 Q2 divided by R square. Here R is the electrostatic, K is the electrostatic constant. Electrostatic constant of the medium between the two charges. And if the medium is air or vacuum, it is called free space, and its permittivity or K is also called permittivity. Permittivity of air, that is epsilon naught, represented by epsilon naught, is equal to 8.854 into 10 raised to the power minus 12 Coulomb square per Newton per meter square. This is the permittivity of air, if the air is the medium between the two charges. So, this is the basic Coulomb law. Now, we see that F12 is the force on charge Q1 due to charge Q2, and that will be equal to force K Q1 Q2 divided by R square. And as F force is the vector quantity, we say that if we take magnitude of the force, then this will be the no sign will be taken, no positive negative will be taken, and this will be, if air is the medium between the two charges, then it will be 1 by 4 pi epsilon naught. Value of k is equal to 1 by 4 pi epsilon naught. Q1 Q2 divided by R1 2 square. This is F12. And similarly F21 will be 1 by 4 pi epsilon naught Q1 Q2 R21 square. But here if we take direction also, then R12 unit vector R12 and here unit vector R21, then this will be a vector quantity. This will also show the direction. If we multiply it with the unit vector here, unit vector of the distance, then it will be a vector quantity. Force will be a vector quantity. Now we see that R12 here, R12 is negative of R21. So we say that F12 is equal to negative of F21. Means by magnitude they are same, they are equal. F12 and F21 they are equal, but if we say direction, then they are opposite to each other. See, F12 is in this direction and F21 is in this direction. They are opposite to each other. And this we have taken the case that both are positive in nature. Charges are positive. If we take negative, both are negative, then same will be the position because there will be repulsion. And F12 will be in this direction and F21 will be in opposite direction. But if we say that Q1 is equal to positive, Q1 is positive, Q2 is negative, then what will happen? F12 will be in this direction and F21 will be in this direction. That this will be attraction, force of attraction, if the charges are different. But there will be force of attraction, but the direction of the force will again be opposite to each other. One force is in this direction and one force is this direction. So this is the Coulomb's law, and we have seen that if F21 force is along with R21, then this will be repulsion, and if F21 is opposite to R21, then there will be attraction. In this way, Q1 and Q2 are having opposite charges, and in this case Q1 and Q2 are having same type of charge. Now we solve some of the problems, and then we can also before I go to the problems, let me tell you that you should remember these terms: charge on electron, and this is equal to 1.602 into 10 raised to the power -19 Coulomb. So In 1 coulomb, there will be charges of 6 into 10 raised to the power 18 electrons minus 1 coulomb. So you can see that coulomb is quite a large unit, and if this much of electrons are collected together, they will give the collective charge equal to 1 coulomb. So by this you can well think that coulomb is quite a large quantity. Now we do some numericals. By numericals it will be more clear. See, here the question is, what will be the electrostatic force between 2 point charges? One is 2 microcoulomb and other is plus 4 microcoulomb. This is Q1 and this is Q2. You can pause the video and try to solve this problem by yourself, and then see what happens. Now let us solve this problem. So they repel each other with a force of 20 Newton. Now what will be the electrostatic force if minus 6 microcoulomb is added to both these charges? See, we say that in first case, when the Q1 is equal to 2 microcoulomb and Q2 is equal to 4 microcoulomb, then F1 will be K, electrostatic constant or permittivity of the medium, 2 microcoulomb into 4 microcoulomb Q1 Q2. F is equal to K Q1 Q2 divided by R square. So divided by R square, and this become K 8 microcoulomb square divided by R square. Now case F2. F2 will be equal to K Q1. Q1 becomes, because Q1 2 microcoulomb minus 6 microcoulomb, this becomes minus 4 microcoulomb. So minus 4 microcoulomb into 4 minus 6 minus 2 microcoulomb divided by, distance is same, R square. This will become, F2 will become K minus 4 into minus 2, 8 microcoulomb square divided by R square. Now see, this is 8 microcoulomb, K into 8 microcoulomb square R square, and this is also the same. Both are same. So we say that F1 is equal to F2, and that will be equal to 20 Newton. So this is the solution of this question. Now other question, what will be the electrostatic force between two charges (2c and minus 2c) which are separated by a distance of 1 millimeter in air? See, in air F is equal to K Q1 Q2 by R square, and it is in air, so K is called permittivity of air, and its value in air is equal to, it is equal to 9 it is equal to 9 into 10 raised to the power 9 Newton meter square Coulomb per Coulomb square. This is the permittivity of air. So now we calculate, this is the constant and its value is this. Now we solve this question, and F is equal to K Q1 Q2 divided by R square, and here we have seen that K is equal to 9 into 10 raised to the power 9, Q1 2 Coulomb, and divided by R square 1 meter square. Now by calculating it, it will come 2 minus 4 and 9 36 into 10 raised to the power 9 Newton. So force will be minus 36 into 10 raised to the power 9 Newton. This is the solution of this question. Now we come to the question number 3. Question number 3 states, you can pause the video and then try to solve yourself the questions. Then you will find, you will practice this and you will get more efficiency in solving these type of questions. Now we solve this question number 3, that is two spherical conductors. There are two spherical conductors A and B with equal radius and equal charges. Radius R is same and Q charges on both the spheres are same. They repel each other with a force F. Now third equal sphere with no charge touched with A and then B and then was separated. What will be the new force between A and B? Let it is Q1 and Q2 are the charges, both the charges are same. So let the charges on the both the spheres is Q. Then force will be K Q square, Q into Q, Q square divided by R square. Now what happens? A third equal sphere with no charge was first touched with A and then touched with B and then it was separated or removed from the system. So the third sphere, when it is touched with A, what happens? That sphere, both the spheres shares the charge Q equally, and here A has Q by 2 charge remained and Q by 2 charge, half of the charge comes to this sphere, touching sphere, third sphere. Okay, now the charge, new charge on A will be Q by 2, and now this a sphere with charge q by 2 is touched with the sphere b, then what will happen? B will share its charge, so that both b and this third third sphere has the both the both has the equal charges. Then what will happen? Q by 4 and q by 4. Q by 4 will be subtracted from this, that will go to this, and it will become 3q by 4, and it will also become 3q by 4. So when the two spheres touch each other, then with equal radius, then what will happen? Both will have the same charge. This you have studied in your class 11th. So the in second stage, A will have q by 2 charge and B will have 3q by 4 charge. Then what will be the force? See, F1 is this in the first case, when both the spheres have q charges, and in second case F2 will be k q by 2 into 3q by 2, 3q by 4. Three q by 4 divided by r square. Then it will become F2 will become k q 3q square divided by 8r square. And what will be the ratio of F1 by F2? Then this will k q square r square divided by k 3q square 8r square. R square to r square, q square k, then this will be 8 by 3. So this is the means the new force F1 by F2. 3F1 is equal to 8F2, or F2 is equal to 3 by 8F1. Means new force जो है that will be equal to 3 by 8 of first force. Now we come on to the other question. See, there are two charges. Q1 is equal to 3 into 10 raised to the power minus 7, and Q2 is equal to 4.5 into 10 raised to the power minus 7 Coulomb. Force acting is 0.4 Newton. What is the distance? See, this is a very simple question. F is equal to K and let the medium be air between the two charges. Then K, force is equal to K Q1 Q2 divided by R square 1 by 4 pi epsilon naught into 3 into 10 raised to the power minus 7 into 4.5 into 10 raised to the power minus 7. R is R square and force is equal to 0.4. Now with this we can say that R square is equal to 1 by 4 pi epsilon naught into 3 into 4.5 into 10 raised to the power minus 7 into 10 raised to the power minus 7 divided by 0.4. Now you can calculate from this, you can calculate the distance, and this I leave to you for because calculation will take much time, and this you can do as your homework. Now we come to the other question, that force F when two charges Q1 and Q2 are separated by a distance R. If both Q1 and Q2 and the distance between them are doubled, then what will be the new force? This is very easy question. See, Q1 and Q2 are the charges. They are separated by a different distance of R. Then force is given by K, electrostatic constant, Q1 into Q2 divided by R square. This is the force. Now he says that Q1 is and Q2 are doubled. Then K 2Q1 into 2Q2 and R is also distance between them is also doubled. Then it is equal to 4 K 4 Q1 Q2 and 4 R square. Then this is the same as this. So there will be no change in force between the two charges. Now other question is, force of repulsion between 2 point charges is F and charges are at a distance of 1 meter. Point charges are replaced by conducting spheres of radii 25 cm each having same charge as that of point charges. Distance between their centers is 1 meter. Compare the force of repulsion in two cases. See, when there are 2 point charges, then force is F is equal to K Q1 Q2 divided by 1 square. Now these are 2 point charges Q1 and Q2. Now he says that instead of these point charges, conducting spheres of radii 25 cm each and distance between the centers Q1 and Q2, that is 1 meter apart. Centers are 1 meters apart, and then what will be the force? If they are spheres, then force will be the K Q1 Q2 1 square, because when we consider conducting spheres instead of these point charges, then we take distance as equal to the distance between the centers of the spheres. So there will be, the forces will be equal in both the cases, and there is no change of force between the two, whether they are point charges or they are conducting sphere charges. Now we come on to the next question, and that is, This is something very interesting question, and let us calculate it. Let us solve it. There are two equally charged metal spheres. Metal spheres means they are conducting spheres, conducting of equal radii, repel each other. Repel each other means both have the same type of charge, identical charge, and force is 3 into 10 raised to the power minus 4 Newton. A third identical uncharged sphere is touched with one of the sphere and placed at their midpoint. Find net electric force on the third sphere. See, let us assume that there are two spherical charges A and B. Both are having same charges, equal each other with two equally charged. Equally charged हैं तो this will be Q charge Q and this will be charge Q. So in first case this has charge Q and this has charge Q. Now a third sphere, let us say C. C after touching A. After touching A, second case, and it is placed, this distance is R. This is placed at the midpoint from here. Then this is R by 2 and this is R by 2. And when this C sphere touched with A, what happens? The charges are equally divided between the two spheres. So it got A got 20 Q by 2 and C got Q by 2. And charge on B remains same because it is undisturbed. So this is the second situation, and here we have to calculate force on, find the net electric force on third sphere. Third sphere means C. So force on C due to A is equal to FCA, that will be equal to K Q by 2 divided by R by 2 whole square. That will be equal to K Q square by R square. If we calculate it, simplify it, we get K Q square by R square. Now force on C due to charge B, that will be equal to K Q by 2, and charge on B is Q, and again distance is R by 2, and if we calculate it, we get 2KQ square R square, if we simplify it further. Now net force on C will be the net effect of these two forces. So net on B, net force on B, C. Net force on C will be equal to FCB minus FCA. Then it will be 2KQ square divided by R square minus Q square divided by R square. That will be equal to, if we simplify it, that will be, this is KQ square. This will be equal to KQ square by R square. So the net force will be equal to the KQ square divided by r square. And in first case, when both when there was no third sphere, in first this case, what was the force? F is equal to k q square divided by r square. Same is the force here. And this force was 3 into 10 raised to the power minus 4 Newton. This. So again, the third sphere will experience the force of this, and this is equal to 3 into 10 raised to the power minus 4 Newton. And what will be the direction? See, FCB is more. FCB is more than FCA. Hence, the force of repulsion by B is more than that of by A. So, the force will be away from the sphere B. It will be away from the sphere B, force of repulsion. So, this is the solution of this question. Thank you for watching, and I request you to subscribe to my channel and share the video to your friends, and please don't miss any of the videos in this chapter, because this is very important chapter as your from your examination point of view. So I will request you again to please subscribe to my channel.